Newton is the first person who actually connected motion and force correctly. Before him, there were some things that we discussed about force, but they were not correct. Even we believe that force was required for an object to move at a constant speed, but now we know that if an object is moving with a constant speed, it does not require any force. Okay? Force is required when we need to increase or decrease the speed of a moving object. So Newton's first law is if there is no force, an object just 1 second. Are you people hearing an extra sound from my side? If there is no force on an object, there will be no change in its motion. Okay, there will be no change in motion. It does not mean that there will be a motion. This statement means if there is no force, an object at rest will remain at rest, and an object which is moving will keep moving with uniform speed in a straight line. So if there is no force, there will be no change. That is the point. No force, no acceleration. This is one other way of saying the same thing. I'm repeating the same thing with different words. If there is no force on an object, there will be no change in its motion. Okay. Another way of saying same thing. If there is no force, an object at rest will remain at rest, which is moving will keep moving with constant speed in a straight line. Same thing. Now, if there is no force, there will be no acceleration. That is another way of saying the same thing. Now, this law is also known as law of inertia. Now, what is inertia? Inertia means resistance to change. Inertia means resistance to change. Now, change in what? Motion. So, an object which is at rest wants to stay at rest. An object which is moving wants to keep moving with constant speed in a straight line. This property of an object is called inertia. And magnitude of that inertia is known as mass. Let me give you an example. What is inertia? An object at rest will stay at rest, and a moving object will keep moving with uniform speed in straight line. Now, some of you might think that it is the same thing as the first law. No, in first law, Newton said that if there's no force, there will be no change. But here, you are understanding why we need a force to change state, because every mass wants to stay in its original state of motion. This property is called inertia, and measure of inertia is called mass. Some people believe that mass means measure of mass, a measure of amount of matter in an object. And it is very common answer. If I go to a class of 40, 30 students and I ask them, oh, what is mass? And the most common answer that I will get, and I keep on getting over the years, is that mass is amount of matter. But mass is not amount of matter, because if you go down the list of basic quantities, you will find amount of matter as one of the quantity over there. So if amount of matter is one quantity, then mass cannot be amount of matter. There cannot be two same quantities in the same list. So mass is not amount of matter. Mass is amount of inertia. How much inertia is there? Let me give you an example. For let's consider I'm in a live class, and you're studying with me, and suddenly I ask you that, oh, I forgot my mobile phone in my car. Can you go down in the parking and fetch my mobile phone? So I give you, any one of you can consider this, like, I give you keys, you go to car, and then you open the car, get the mobile phone and bring it to the classroom. Now let's consider it as job number one. Job number two, uh, on another day I say that, okay, I need a bag of cement, a 10 kg bag of cement, and I have that in my car. Take my keys, go and fetch that bag of cement from there. Now consider this second job, compare it with the first one. The first job was easy. You had to pick a mobile phone, come back to the classroom. Now the second job, you have to pick a bag of 10 kg cement and come back to the class. The second job, you know it will be difficult to get the bag out of the car. It will be difficult to walk with the bag, and it will also be difficult to unload the bag. So this difference of difficulty is called math. Yeah, this is one example. Now take it and take another example. You're standing on a pavement on the side of a building. This is a tall building. This is a very tall building. On the top of the building, there is your friend, and here you are. Okay, and you're standing on the pavement. Now, suddenly, your friend's mobile phone, new Apple 14 or something, the latest and most expensive phone, he drops it, and you are here. You are a good person. Your friend is a good person. So you see the mobile phone coming down. You are in a position that you can come in the way, catch the mobile phone, and make it not hit the pavement. Will you dare to come in the way of the mobile phone's flight and stop it from hitting the ground? How many of you will try to save your friend's mobile phone? Okay. So only one? Okay. Just okay. Good. I got an answer. He said, I wouldn't. Good, good. Now, just consider it as job number one. Job number one is you have to stop a mobile phone that comes in front of you with a speed of about 25 meter per second. Okay. And you, if you want to stop it, you can. If you don't want to stop it, it is totally up to you. Let's consider a bag of cement, a 20 kg bag of cement or 10 kg, let's make it the same, is coming down with the same speed of 25 meter per second. Will you dare to come in the way of that cement bag and try to stop it? It is coming down with the same speed, but you know it has more inertia. It will be more difficult than a mobile phone. It is easy to stop a mobile phone when it is moving at a speed of 25 meter per second, but it is less difficult to stop a mobile phone when it is moving at a speed of 25 meter per second, but it is more difficult to stop the bag of cement. This difference of difficulty is called mass. And we name it inertia. Okay. So mass is not amount of matter, but it is something that depends on amount of matter. If something depends on another quantity, it does not mean that it is the same quantity. For example, speed depends on time, does not mean speed and time same thing. So there are two different things, but they're dependent on one another. So mass is a measure of inertia. Now, Newton's second law. Rate of change of momentum is directly proportional to net force. This is one way of saying it, or net force is directly proportional to acceleration if mass is constant. If mass is constant, net force is directly proportional to acceleration. So F is directly proportional to A, and F equals to MA. Mass in this formula must be in kg. Acceleration must be in meter per second square. That means force will be in kg meter per second square, which is also known as Newton. Now, one Newton to produce an acceleration of 1 meter per second square in a mass of 1 kilogram, we need 1 Newton of force. So if somebody asks you what is 1 Newton, you can say it is a force that can produce an acceleration of 1 meter per second square in a mass of 1 kg. Now, still the same thing is continued. If there is a forward force of, this is F applied force. This is resistive force. This is the direction of motion. This is applied force. This is resistive force. Resistive force is the one that opposes the motion of an object. Then net force will be applied force minus resistive force. F minus Fr is the net force. So F minus Fr is equals to Ma. So this is a very common formula. This will be most common formula that we use in mechanics when we are calculating forces, especially when forces of motion are related with one another. F minus Fr equals to Ma, where F minus Fr together, this is net force. This thing is called net force, which is equal to mass times acceleration. Now, we will be doing multiple examples of F minus Fr in this course. But before that, I want to do the list of forces that we need to know. Now, what is Newton's third law? One way of saying this is, and I will not recommend that you state Newton's third law like that. Every action has an equal but opposite reaction. Every action has an equal but opposite reaction. Or if object A exerts a force on object B, then object B will exert an equal but opposite force on object A. This makes more sense that when A exerts force on B, then B will exert an equal and opposite and of same kind of force on A. Like if A pushes B, then B will push A. If A pulls B, then B will pull A. So there will be a same kind of force acting in exact opposite direction between two objects. And this pair will never cancel one another because they are never acting on the same object. For example, if this is A, this is B, this is A, this is B. A exerts force on B, then B exerts a force on A. This is force of A on B. This is force of B on A. Force of A on B is exactly equal to force of B on A. So both of the forces are equal and opposite. And they will never cancel one another. You know why? Because they're never acting on the same object. They're acting on two different objects. So forces that act on different objects, they do not cancel one another. For one force to cancel another force, it must be acting on the same object. Okay. Now, one type of force is called tension. What is tension? A force that act a pulling force that is applied by a rope spring or chain is called tension. This force always acts away from object along the direction of stretched rope. Now stay with me. Tension normally gives tension to the student. Tension always acts away from an object along the direction of the rope. For example, there is this object and here you are. Okay. Now you are pulling this object towards you. Now, look, this is a mass, and there will be tension in the rope. This is stretched rope. So this will be pulling the object away. So direction of tension on this object will be away from the object. And that is true for every tension. It is always acting away from the object along the direction of the rope. Okay. This is mass M, which is which has been acted upon by a force, and tension is simply a force acting away from the object along the rope. What is happening on the other end? On the other end, this is the other person, M. And what is happening? This rope is exerting force on M in this direction. So tension always acts in a direction away from the object. So same tension, but it will be acting when we will look at this person, the direction of tension will be towards right. And when we will be looking at this object, the direction of tension will be towards left. And this is done by the same rope. So same rope is exerting force into opposite direction. This is what we call tension. Now, one note, one stretched spring rope or chain can only have one tension at a time. So tension will be same on both ends. So it is not possible that the tension on object is more than the tension that is on the person, or tension is less than the tension on the person. So it will always be same. Now, after tension, resistive forces. Forces that resist motion or always resist motion are called resistive forces. Common example, drag force and friction. Now, what is drag force? What is friction? Now, drag force is force that fluid exerts on a solid that moves through the fluid. Now, listen, if this is a room, what is filled in a room that you are sitting right now? What is the thing that has completely filled your room right now? Answer is air. Your surrounding is filled with air. Now, for example, this is you. and you're walking like this. So when you walk, for example, let me make you walk here. So if you're walking like this in the room, or going like this in the room, do you know that what you're doing continuously? You are dealing with the molecules of the air. Right now, if this is where you are, don't you think this is the region you have displaced the molecules from? Because now you are there. If you outline your body, you're definitely occupying some space. So wherever you go, you have to make the molecules move away from there. So when you are moving this way, you will have molecules. Let me make some here. So there are molecules like this. So when you move through them, let's see if I make one molecule here. So you exert force on the molecule, and then molecule exert force on you. This will be an equal and opposite force. One molecule, that will be a very small force, but multiply it with the very large number, you will get a significant amount. So whenever a solid moves through a fluid, it experiences a backward force, and that backward force is called drag force. And that drag force is because of the motion of the, like for example, if you're stationary, perfectly stationary, not moving at all, not a single muscle is moving, then you're not disturbing the molecules of air around you, and they will not disturb you. So there will be no drag force. So drag force depends on motion of an object. So an object moves, pushes the molecule, and then molecules push him back. That will be called drag force. For example, there is a storm in a city, and I'm standing on a roadside, and I'm against a very strong wind that is trying to pick me up and throw me on the side. Will that be air resistance? Answer is no. That is a wind force. Air resistance is when I move, I push molecules of air, and air molecule push me back. That would be air resistance. And that for that, what is necessary is that I am moving. If I'm not moving and the force is acting on me because of the motion of the air, that will be wind force, not air resistance. Now, when any solid moves through fluid, fluid means gas or liquid, it pushes on molecules of fluid which push the solid back. Newton's third, right? So obviously we're not talking about Newton's third child, it is Newton's third law. So Newton's third law is that when object A exerts force on object B, then B exerts an equal and opposite force on A. So when a solid object pushes the molecules of air, then molecules of air push the solid object. And this push of the molecules of the fluid as a reaction is called drag force. Drag force that acts due to air is also known as air resistance. factors that affect drag force. Number one, front area of moving object. Two, speed of moving object with respect to fluid. Number three, density of fluid. What is meant by with respect to the fluid? When you are sitting in a car and the car is moving, the air inside the car is also moving with you. So you do not feel any air resistance because although you are moving, but you are not moving with reference to the car that is already in the car. But if you open a window and make your face go out or make a hand go out, in that case, that will be air resistant. So you are moving with respect to air outside the car, but you're not moving with respect to air in the car. That's why if windows are closed, then air which is inside will be you will not be feeling any air resistance because of that. The speed of an object with respect to fluid, density of the fluid. These are the things that control the size of drag force. Drag force is directly proportional to front area. It is not the area of the whole object. It is just the area of the front of an object that matters. So drag force is directly proportional to area. Drag force is directly proportional to square of speed, and drag force is directly proportional to density. Now you can ask that why it is directly proportional to square of speed, because there are two reasons when speed increases, drag force increases. Number one, when you have more speed, you will be hitting the molecules harder, and there will be more change of momentum. So there will be more change because there's more change of momentum, there will be larger force acting. So when you have more speed, you will be hitting molecules harder, so molecules will be hitting you harder. Secondly, if you have high speed, you will be dealing with more molecules. So there are two reasons. That's why there is a square on speed. So drag force is directly proportional to area, bigger drag, smaller area, smaller drag. That is why we make the modern high-speed cars very leaky and very aerodynamic. Secondly, it is the speed. If you increase speed, the drag force increases, and the density of the fluid. Uh, if you have any experience of walking in a swimming pool, you might agree with me. It is not easy to walk in water. It is easy to walk in air, but it's not easy to walk in water. Why? Because when you walk in water, you deal with more molecules because there are more molecules in a certain volume. So molecules that affect the size of drag force. Now, what is friction? A stopping force stopping force between two surfaces due to interlocking between them is called friction. So if this is a table, just 1 second. This is table, and on the table there is a book. Now, if we make the book move this way, we might not be able to see it, but if we magnify this region, we can see that the book surface will not be as smooth as it looks. And same goes for the surface of the table. So this is surface of table, and this is surface of book. And these interlockings, they cause friction. So friction is another kind of force that affects motion or that resists motion. Okay. So when we say resistive force, total resistive force, it will be drag force plus friction. Okay. So total resistive force is always drag force and friction. And these are two separate resistive forces. The common thing in them is they both resist the motion of one object on the other. They are motion haters. They always hate motion. So that's why they always resist motion. Now, okay. I think this is it for today. We will resume. We have done resistive forces, net force, normal contact force, and upthrust. That will be done in the next class. Thank you very much. See you tomorrow, same time.
Allah Hafiz.
Allah Hafiz.